Howdy. Welcome to my hackathon project, Dynamic Recon Ornithopter Natural Emulation Bionic Integrated Radio and Video Design, otherwise known as DroneBird. As many of you may know, surveillance and spies are two very interrelated topics. Oftentimes a spy's mission relies heavily on how well the area in which they're operating is surveyed and how well data is gathered about the area. Traditional surveillance options include CCTV cameras, UAV imaging, and line of sight. As you can see, there are cons to all these options, and sometimes they simply cannot be used in every environment. So what happens when these traditional methods can't be used in a specific mission? Well, that's when your very own UAV in a bag comes in, the DroneBird. Here's some renderings of the DroneBird from top, from the same view, and just with the wings extended, with the wings unextended. But yeah, some specifications for this product include the weight of only 513 grams and the fact that it only consists of 24 parts. The flight time of my DroneBird is capable of about 2 hours at normal operations and up to 20 minutes at high-speed operations. So, funny enough, the only reason why I was able to calculate the values for how fast this bird, my product, would be able to fly was because somebody asked the question, what is the airspeed velocity of an unladen swallow? And because of that, I could very easily take an equation and compare it to actual data points made by J. Penny Kuick in his linked article about birds and radio waves. But yeah, I was able to get an approximation for a bird that is most like my design, and in this case ended up being the great skua. The weight and wingspan both mirrored my wingspan and weight pretty closely. So with that, I was able to take those values that were given in this essay, which were 15 beats a minute at a 3.8 meter wavelength, so that's wing up and wing down, and then at a speed of approximately 7.2 meters per second was how fast the wing was moving at any given moment during the beat. So here's some general dimensions of what my bird drone looks like. We have a 50-inch wingspan and a 30-inch horizontal length. Some more specifications would be the fact that I have a 4600 kV motor, 2 batteries for extended flight time, both running 3 cells at 1000 milliamps. Flight controller is an X-rotor flight control system. I picked this one because it's lightweight and because it has the option for integrated code control, so we could add dynamic systems to identify targets and track them via vision processing, but these are options that can be explored later on. Oh, whoops, and as you can see also there's an onboard DVR that can record up to 500 hours of footage, and the FPV transmitter, which can transmit video up to 500 yards away. Here's just some more renders of the bird. And then a proof of concept. Somebody has developed something like this before, however it was mostly made to scare away birds in an airfield, and as you can see it's very simple, almost
Concept
the same
behind
design.
it is
and theirs actually ended up weighing more than mine did. Theirs was 750 grams. So yeah, now we're gonna hop into the actual CAD of the bird. So as you can see, we have our main body, 2 batteries on the other side, the motor, our camera for video, and so you can have long range, line of sight flying. Here's our gear attached to this other gear, steps down the speed of the motor, less rotations. And we have our driving arm for each wing that is also attached by this crankshaft. We have our electronic board. Here's our flight controller, our DVR, our power distribution panel, and our FPV transmitter. We have 2 servos controlling both the pitch of the bird, and then this one right here controls the roll of the bird. So this rudder right here has the ability to turn 180 degrees either way. And same with this thing. This thing can move like an elevator would on a plane. And then here we have our wing flaps. Just to demonstrate this, we can get a nice view of it. So we can, if you look at this motor right here, we have this in the upward position right now, because it's in the upward position of the wing. And if we drag it down, you can see it's now in the downward position. See the hole is now below that. Just as the gear spins, it'll drive this up, down, creating that. As this gear spins, it'll create an upward and downward movement for the bird to use to fly. This can be controlled by the motor and can spin up to something like 15,000 RPM, I think, just crazy fast. Yeah, I think I'm going to attach a rendered video of this thing clapping its wings, and I think we'll be done. Thanks for watching.